Start server, start client. This is case one. And we can see the resending is resending packets. Yeah, let's pause here. Now you can see after a long time period, we have reached to the end and we have finished our sending from the client to server in 2000 seconds. Need to mention that we have changed our thread number from 4 to 16, which is actually the window size we have configured. For this reason, the because the network delay is quite big, and we need to increase our window size to ensure we have enough bandwidth. Now finish the case one, we need to set the MTU to 9,000. Oh, just this command. Okay, both client server have the MTU of 9,001. And we also set on the router side. Okay, now we can modify our code, increase the payload size to like 8,000, 8,080, 800. Save, compile, and run the code. Start running the code. Yeah, let's pause for now. Just wait it until it's done. Now the program has finished with only 350 seconds, which we can see it dramatically reduced the time we spent just increasing the payload size without changing anything else. So this is how the MTU works in different scenarios. Now let's test the case two. For the case two, we have to, so let's first make a screenshot here. And for case two, we need to set the RTT and the drop rate. Both for ETH1 and ETH2. And we can ping from here to see the already increased. Let's see here, ping. We can see this is the actual latency, and we can see this very unstable here because there are loss rates very high, 20% of loss rates. Stop here. And then let's test our code. Well, I can see the resend rate is dramatically high. Oh my god. So let's pause here, wait for it's finished. Like, wow. We have to keep resending the packets. Now let's test case 3. First, we have to remove all of the previous configurations. So here we have removed all of them and added new configurations. So we can use sudo tc qt to show that there are 8 bit burst limit and 100 milliseconds delay. This is route settings, and for the client settings, we need to enter this command ETH0. Copy here. I don't want to use ETH0. Let's use what? Oh, looks only missed 9. Ah, yes. This is the command we need. Set it. Set also for the server side. Now everything should work fine. Let's see. Let's see the throughput for the TCP. Let's see. Oh, for this one. Yeah, we can see the byte rate. Already limited. Because we have limited is to 8 mbit per second, 18, so it should be let's see if we can increase it using UDP. Which is okay. Yeah. test the for this task we need to test this loss rate. Yeah, it's roughly like 14-15%, which matches the photo we see on the PDF, which is like 22, similar, right? So it's acceptable for the result for now. Let's give it a screenshot. So I assume the network's environment is settled and is set. We can start testing. Let's test case 3. Oh, let's test the ping delay. Should be 200. Yeah, 200, which is our settings. Okay, let's stop this one and let's try. Oh, let's see if we have anything we need to do before actual testing the code. For case 1, 2, perform 1 GB file. Um, client link speed set to 100. So what should I do? For case 3, record performance FTP. Okay, all the same. So let's begin. You can see it's sending. Oh, it's no. The current size not what we need here, and it's also using the smaller data. Remove this one. Everything should work now. Let's compile the code and run. Oh, here. Yeah, if everything works fine, we should not see any debug message except the ACK and send. If something went wrong, there will be resend messages showing up. So it looks fine for now. But since the throughput is like really shrinked, so more time should be expected before anything is done. So we should pause now until we finished our sending. For demonstration purpose, we switch our method using another alternative way to proving our transmission time and the throughput using so currently we are using a small data instead of the 1 GB data, which is really big and waste of time, actually recording the how long we actually transfer data. So actually here we will use a smaller data of 32 MB, and we'll test it, transfer it actually, and test how long we use to transfer this data, and well, then we can calculate the transfer speed. So here we go. Let's compile and run. It's the server side listening. Yeah, first 1,000 packets has been sent. So actually from here we can calculate the transfer speed instead of actually really transfer that 1 GB file just for the demonstration purpose. The actual transfer time and the record are sent it on the report. Here, yeah, it's really meaningless to do, to wait till the packets are sent. So we can see here there are 3,814 packets, and the more time we spend sending, the more packets we will encounter when we have to resend. Encounter which actually need to be resent. So here we encounter more and more frequent resent request. Because of timeout, because the actual network delay is 200 milliseconds, and our timeout time is set to 500 seconds milliseconds. So you can see here I'm transferring 32 MB megabytes file cost 121 seconds. So we can actually calculate the time if we transmit the actual 1 gigabit file here. So that's it.